Yes. So last time we considered discovery of electrons. Electrons, they are negatively charged particles. Now, right now, today's topic is discovery of proton. Discovery of proton. Now, listen to me carefully before I start dictating. See, an atom is electrically neutral. It doesn't carry any charge on the whole. Overall, it is neutral. And we already considered the topic where we discussed discovery of electron. Electrons are negatively charged particles. So if presence of negatively charged electrons is confirmed in an atom overall is neutral, it shows that some positively charged particles must also be present in an atom. For that, again, cathode ray discharge tube was used, and that was slightly modified. What was the modification this time? I'll draw a very rough diagram. You remember last time I told you anode is perforated. Anode has holes in it, and this portion of tube behind anode is coated with zinc oxide. This time, cathode will also be perforated, and glass tube behind cathode will also be coated with zinc oxide. Zinc oxide, I told you, is a fluorescent material. Same experiment, production of cathode is carried out. If you remember, one of the properties of cathode rays, I told you, cathode rays cause ionization of the gas. Ionization means removal of one or more electrons from gaseous atoms or gaseous molecules. When one or more electrons are removed, leftover part will be positively charged. So positively charged ions will be produced after ionization of the gas. Those positively charged ions produced will travel in the opposite direction, means they will travel towards cathode. Since their direction of motion is from cathode towards anode, they are called anode rays, and they consist of positively charged particles. Moreover, if we take hydrogen gas in this discharge tube, first of all, H2 molecules will split into H atoms. These H atoms will lose one electron and will lead to the formation of H plus ion. These H plus ions are the lightest anode ray particles. I'll repeat, anode ray particles produced by taking hydrogen gas in the discharge tube is found to be made up of lightest particles. And they carry 1 unit of positive charge. 1 unit of positive charge is nothing but same charge as the charge of electron, that is 1.6022 into 10 to the power minus 19 coulomb. But nature of the charge is positive. That's why we call it 1 unit of positive charge. And the mass of this lightest anode ray particle produced by taking hydrogen gas is called 1 unit of mass. These positively charged particles produced by taking hydrogen were named as protons, right? So first I'll dictate you this much, then we'll proceed further. Pattern heading is discovery of proton. Pattern, since an atom is electrically neutral and presence of negatively charged electrons was confirmed on the basis of production of cathode rays It means that some positively charged particles must also be present in the atom. To prove this, electrical discharge through gases was carried out at low pressure in a modified cathode ray tube, in which cathode used was perforated, had holes in it. This led to the discovery of another type of rays which came from the side of anode passed through holes of cathode and produced glow on ZNS, zinc sulfide coating behind cathode. These rays are called anode rays or canal rays. Anode rays or canal rays. Next paragraph. When hydrogen is taken for the experiment, anode rays produced consist of lightest positively charged particles. Their mass is almost equal to the mass of a hydrogen atom, which is called 1 unit mass. They carry 1.6022 into 10⁻⁻19 coulomb. That is 1 unit of positive charge. It means the quantity of charge on electron and proton is same. The only thing is nature of charge is different. Electron carries negative, proton carries positive charge. Quantity is same. They are called protons. They are called protons. Next topic, rather subtopic, part of this particular topic, write on the heading properties of anode rays. Properties of anode rays. Number one, they travel in straight line, but their speed is less than the speed of cathode rays. This proves that they are much heavier than electrons. Much heavier than electrons. Number two, they rotate a light paddle wheel. I told you about paddle wheel last time. Rotate a light paddle wheel, which proves that they are made up of material particles. Means made up of some particles which have mass. Number three, they are deflected towards negative plate in an external electric field which proves that they consist of positively charged particles. That is why anode rays are also called positive rays. Also called positive rays. Now, next 3 points, point number 4, 5, and 6, you just write down. I'll explain all the 3 points together after I have dictated. Number 4, charge on anode ray particles is a whole number multiple, 1 time, 2 times, 3 times, and so on, whole number multiple of the charge on an electron, but of opposite nature, negative and positive. Next, number 5, mass of anode ray particles depends on the nature of gas taken in the discharge tube. And it is almost equal to the mass of neutral atom or molecule, neutral atom or molecule of the gas. Last point, number 6. Nature, that is E by M ratio, nature, that is E by M ratio of anode ray particles depends on nature of the gas taken in the tube. Nature of the gas taken in the tube. Now for last 3 points, I'm explaining on the board. You need not copy it, although it will always be available on YouTube video. You just look here. Electron, proton, neutron, right? Total charge. After that, total mass. Mass in terms of units of mass. And last will be E by M ratio. Just understand. Now, what we know about nitrogen atom today is that one atom, one neutral atom of nitrogen contains 7 electrons, 7 protons, 7 neutrons. Mass of one neutron and mass of one proton is almost equal. That is 1 unit of mass, 1 unit of mass. It means total charge will be -7 plus 7, 0. Total mass will be negligible, +7 plus 7, 14. E by M ratio will be 0 divided by 14. We do not consider E by M ratio of neutral particles. Now we consider again nitrogen atom after removal of one electron. After one electron is removed, number of protons and neutrons does not change. Number of electrons will become 6. It means total mass will be 7 plus 7, no change. But charge, this will be -6 charge plus 7 charge. It means charge will be 1 unit of positive charge. E by M ratio will be 1 divided by 14. Now, if 2 electrons are removed from nitrogen atom in the discharge tube, -2 electrons, then electrons left will be 5. Protons and neutrons will not change. Charge will be +2 because this is -5 and +7, +2. Mass will not change, 7 plus 7. E by M ratio will be 2 by 14. It means, what is the charge on anode ray particles? That will be different depending on how many electrons have been knocked out. But this charge will be a whole number multiple of the charge on electron. I'll repeat, whole number multiple of the charge of an electron, but opposite nature. Electron has -1 charge. This has +1 or +2 charge depending on how many electrons have been removed. Similarly, E by M ratio will be different, which will depend on how many electrons have been removed. You can see the numerator, and will also depend on what is the mass of particle. Now, in place of nitrogen, if we take oxygen, then mass will be 16 units of mass, because one atom of oxygen contains 8 neutrons, 8 protons. mass will be 16, denominator will be 16. Numerator value of numerator will depend on how many electrons have been removed, right? So these were point number 4, 5, and 6, which have been explained on the basis of this exam. Next topic, again, part of this particular topic only. Heading, origin of anode rays. Origin of anode rays. See, if you remember, I told you in cathode rays, I told you cathode rays are first produced at cathode. After that, they are also produced by ionization of the gas. But the same is not true for anode rays. Anode rays are not produced at anode. Rather, anode rays are produced only by ionization of the gas taken in the discharge tube. Write down. In the discharge tube, high energy electrons of cathode rays strike particles of the gas and knock out one or more electrons. This produces positive particles which constitute anode rays. Thus, anode rays are not produced at anode, rather they are produced by ionization of the gas. They are produced by ionization of the gas. So that was about discovery of protons, nature of anode ray particles. So conclusion is that nature of anode ray particles depends on nature of the gas as to which gas is taken in the discharge tube during the experiment. So we have finished discovery of electrons, discovery of protons. Now the next major particle is neutrons. Write on the heading, discovery of neutrons. Discovery of neutrons. Now for this, listen something I'm explaining, then I'll dictate. If you remember, I told you that the mass of one proton is called 1 unit mass. Mass of one proton is called 1 unit mass. Now, if we take a gas other than hydrogen in the discharge tube, if we take a gas other than hydrogen in the discharge tube, then the mass of anode ray particle is found to be a whole number multiple of the mass of a proton. 2 times the mass of a proton, 4 times, 20 times mass of proton, and so on. So I'll repeat, if we take a gas other than hydrogen in the discharge tube, then the mass of anode ray particles is found to be a whole number multiple of the mass of a proton. Naturally, from this, earlier scientists, they concluded that number of protons present in an atom is a whole number, and this whole number is whole number multiple of number of protons. For example, if oxygen O2 is taken in the discharge tube, then anode ray particles produced by O2 molecules, they are found to be 16 times heavier than the mass of a proton. Since one positive particle, one anode ray particle produced by O2 is 16 times heavier than a proton, earlier scientists, they concluded that there are 16 protons in the nucleus of 16 protons in the nucleus of an oxygen atom, because O2 splits into O and O forms positive ions. So O2 changes into oxygen atoms, one or more electrons are removed, and one anode ray particles of O atom, 16 times heavier. Scientists concluded that one oxygen atom contains 16 protons, which of course is wrong. Then came the scientist called Moseley, Mosley. What he did, he determined actual positive charge on the nucleus of any atom. I'll repeat, Moseley calculated exact positive charge on the nucleus of any atom. He calculated that the charge on the nucleus of an oxygen atom is 12.8176 into 10 to the power minus 19 coulombs. I'll repeat, Moseley found that the charge on nucleus of one oxygen atom is so many coulombs. Now we know the charge of one electron, we know the charge of one proton, quantity is same, nature is different. Now if we divide total charge on the nucleus of oxygen by the charge of one proton, how much is the charge of one proton? 1.6022 into 10 to the power minus 19 coulomb. So if we divide total charge by the charge of one proton, value comes out to be 8. It means this proves that there are only 8 protons present in the nucleus of oxygen atom, not 16. It means, how do we account for 16 units of mass? This proves that apart from positively charged protons, some neutral particles are also present in an atom, and these neutral particles were named neutrons. But their discovery was done by Chadwick. What Chadwick did, he bombarded beryllium and boron with high-speed neutrons, which led to the production of neutral particles, that is neutrons, and the mass of a neutron is almost equal to the mass of a proton, although slightly more, but almost equal. Right on this much. That was about discovery of neutron. Right on. Yes, when a gas other than hydrogen is taken in the discharge tube, from a mass of anode ray particles, was found to be a whole number multiple of the mass of a proton. From this, it was concluded that number of protons in an atom is a whole number. For example, one anode ray particle of oxygen was found to be 16 times heavier than a proton. From this, it was concluded that one oxygen atom contains 16 protons. Within brackets, write down, although wrong. 16 protons is not correct, but that was concluded at that time. So within brackets, write down, although wrong. Next paragraph. Next paragraph. Mostly, Moseley, mostly determined exact positive charge on nuclei of different atoms. For example, charge on nucleus of oxygen atom was found to be 12.8176 into 10 to the power minus 19 coulomb. That is, keep on copying down from the board. That is 12.8176 into 10 to the power minus 19 divided by 1.6022 into 10 to the power minus 19 is equal to 8 units. 8 units of positive charge. This proved that nucleus of oxygen atom contains 8 protons, not 16. Thus, out of 16 units of mass, 8 units of mass of oxygen atom is due to 8 protons and Remaining 8 units is due to some neutral particles. Some neutral particles. Next paragraph. Later, Chadwick you should know the year in which neutrons were discovered, 1932. Later, Chadwick bombarded light elements like beryllium and boron with high energy alpha particles. What are alpha particles? I'll tell you in the next class. High energy alpha particles, and found that some neutral particles are produced whose mass is almost equal to the mass of a proton. Within brackets, you can write slightly more, right? Negligibly more. These particles were named neutrons. These particles were named neutrons.